I did that in one take.
We should celebrate this moment.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
I'm Dan Maloney.
This is episode 223. Today we'll be talking smoking smart meters, 489 megapixels, and unshredding documents. Whew, you come back from a week's vacation and Hackaday is still running.
And you have to remember what you do for a living, right?
Oh my god, the week and a bit of email pile up is just a horrible avalanche. It reminds me that someday I need to get a good email client. Anyone with good tips as to an email client that runs offline that has good sorting and automatic categorizing abilities, let me know.
Because it sure ain't Gmail.
No, Gmail doesn't do anything automatic, and so that's right out. I use Mutt. I guess I use Neo Mutt, which is absurd. I'm not loving using a text-based email reader. It doesn't bother me either, but, I could enter the 1990s
Yeah,
comfortably at this point.
Join us here in the 90s, please.
This is actually Mutt's motto, is that all email readers suck. This one sucks too, but it's just not as bad as some of the other ones. And I think that's true, unfortunately. I have never found an email reader that doesn't particularly suck. So
Bit of a wordy motto, but...
Well, they put it more pithily. I can actually go fetch it if you want. Yeah, email client... The Mutt email client, all mail clients suck. This one just sucks less. That's their official motto. And
it's much pithier that way.
That's good. That's good.
Yeah.
Yeah. All right. They got me. Anyway, clever, smart, automatable, scriptable mail clients. Send me links in the show notes. Hackaday.com/podcast. In the news this week, Eagle, a PCB layout tool, CAD tool, is going to be sunsetted. It got bought up by Autodesk a while ago, got kind of rolled into Fusion, and they are no longer going to be supporting standalone Eagle. Jenny wrote this piece of news up when it was very fresh, and the comments are, of course, full of people who are sad to see their PCB design tool getting sunsetted, which of course makes sense.
It's too bad that it's got to go that way, but, a business has to know its customers and has to make money. So, sorry, let's find something else, there's always KiCad, depending on how you want to say it.
Yeah, I actually used to be a long-term Eagle user back when it was maybe up to about 10 years ago. I actually left for KiCad before it got bought by Autodesk. And I really just did that for goofy ideological reasons. Plus, also about 10 years ago, I would say KiCad finally got, quote, usable. Although, you hear people now saying with version 7, KiCad's finally, quote, usable. I don't know what usable means. I've been making boards with it the whole damn time. It was usable before I was using it. I mean, that's proof. Just like email readers, all CAD/CAM software sucks. It's just some of it sucks less or it sucks differently. Like Eagle's finger twisting shortcuts were no good. And switching over to KiCad, of course, you've got a completely different set of no good keystrokes and stuff. So, you can't win. You just have to learn the tool that you got. And I think that's actually, I'm going to be talking about FreeCAD coming up shortly, so we'll keep rolling on this theme in a second.
Yeah, that was even one of the comments that I read in that article that you're going to talk about is talking about the finger twisting shortcuts but I'm used to it. I know I should get used to another tool, but my fingers have another idea.
And that's a real cost, and I understand it. But those of you diehards out there who are still hanging on to your old copy of Eagle from before it went subscription, of course it still works. And, I guess the dream of forever software is there until some operating system no longer supports it. But I think at the same time, the real truth is that the rest of the community will be moving on software-wise. And so if you are stuck using software that no one else is using anymore, especially in kind of the open source sharing, everybody working collaboratively on things together world that we live in, it's really important to be able to play along with everyone else. And yep, Eagle looks like it's a dead end now. On the other hand, It's super easy to get your Eagle files converted into KiCad, for instance. And actually, that's one of the things that I think is really strong about KiCad is that it imports files in from essentially every layout tool I've ever seen that has a halfway reasonable file format. So come join us. What about you, Dan? What's the news last week?
Well, while you were away, we decided to play a little bit. We had a hack chat on Wednesday, and it was getting started in ham with Mark Hughes and Bo Amber. I didn't think it was going to be anything super special or anything like that, but it really was a lively chat. We had a lot of people come in, so most people we've had all year. Go check it out. I think Tom wrote it up as he writes up the summaries on Friday, and I think he did one on this one, so you can get an outsider's perspective. One of the things that came out of it was someone said, hey, wouldn't it be a great idea if we could continue this discussion all the time? Could you set up maybe a channel for that? And I said, hey, yeah, I guess maybe that is a good idea. We should probably do that. So I pinged Tom and had him put another chat on our Discord server. And now we have a Ham Shack chat on Discord, which has become very popular. And there's a lot of people on there pretty much daily, putting content out, sharing tips, saying hi, organizing themselves into, this little community of basically what I billed it as was Hackaday's virtual ham club. Go check it out. I'll put a link in the show notes. It's pretty easy to find, and everybody just goes and talks. And one person made a suggestion about how, wouldn't it be nice if there was a bot that just kind of shot random test questions from the technician test or extra test or advanced test? And I said, yeah, that would be great. Oh, I'm going to sit down and write that. And I'm starting thinking about, I'm writing a bot and what it's going to do and all that stuff. And I'm like, I better check to see if somebody's already done this. And lo and behold, somebody has already done this. There's a bot that you can just invite to the chat, and it'll do exactly that. It'll put out test questions, and everybody can solve them together, or you can do private sessions. And so hopefully we'll be adding that.
That's pretty cool. Yeah, I came back from vacation and I went and I saw it there and I'm like, oh, cool, new channel. I'll go check that out. And I'm like, what the heck? Scrolling back for days and days and days.
Yeah.
So yeah, no joke, tremendously active. The irony of a Ham Shack like rag chew session going on online with you all typing and not a single one of you firing up a radio is not lost on me.
Okay. But in our defense,
owned.
We really should come up with an on-air equivalent, a presence on-air, that, a net check-in, something like that. We really should do that. This is a good place to organize something like that because you can't just, shout into the void and hope people find it.
Yeah, exactly.
There's got to be some sort of scheduling. There's got to be some sort of organization, and this would be a great way to do it. So it's a start, and hopefully we'll get an on-air presence. And I think someone even mentioned, we should really do something at SuperCon. We should set up an event station at SuperCon and maybe even get people to take the tests. And I mean, there's a whole bunch of discussion about that kind of stuff, and all of that can go on the Ham Shack chat on Discord.
This is a journey into sound.
What's that sound?
What's that sound?
Well then, let's head on over to What's That Sound? This week I've got something that's, I think it's going to be a little bit easier. Let's see what happens.
All right. That sounds like a...
Probably.
Probably.
Can you be more specific than that?
It's something...
Probably.
It's probably...
Probably.
Probably.
Full points, Dan Maloney.
Thank you.
If you out there listening have an idea what this is, head on over to hackaday.com/podcast, find the form, fill it out, give us your handle, the answer, and then we'll draw from among the right answers. And if you're lucky, you will get a Hackaday podcast t-shirt. Well, I wanted to start out my hacks this week with a write-up of a pair of videos about how to use FreeCAD, using FreeCAD to replace OEM parts This is a video series by Mango Jelly, and if you are using FreeCAD at all or you want to get started, I actually can't recommend Darren Stone alias Mango Jelly's tutorials highly enough. The one featured here is actually a two-parter where he's making a very complicated hinge part, and it's got, things going on in all directions. It's got fillets, it's got round bits, and he's got a dimensional drawing that he's starting with, and he uses this particular technique, which he calls the intersection workflow. If you haven't been designing parts like this, it's really kind of a little bit of an eye-opener, actually. You know how when you have those dimensional drawings, they'll do like a top view and a side view. It turns out if you for many objects, if you have the top view and the side view, and then you kind of extrude them both out. So you take like the base shape and you make it a big tall cube, and then you take the side view and you make it a cube going in. The object you actually want is the intersection of these two views kind of padded out. And that's basically the trick here. He has a really beautiful walkthrough of this workflow, though, and this will help you whether you use FreeCAD or Fusion or any of the other parametric sketch-based design CAD programs, because he's using all the tricks. Like, he's got symmetry stuff going on in the part, so he's using that, so he only has to do half the work there. He's kind of doing all of this over the top of the dimensional drawing, so he's actually drawing his CAD sketch right over an image of the drawing, which is actually a fantastic trick when you want to make organic shaped parts, or if you want to make something that fits into something you have a picture of. This kind of workflow is really great with technical drawings, with dimensional drawings, of course. It's super easy because you're like, well, how curvy does this need to be? Oh, it's a 6mm radius, and you just type in 6 and you're done, right? Anyway, really, really cool, but an hour's worth of video, and I've been trying to teach myself FreeCAD for the past 2 years now, and I'm decent at it, and still I picked up some tricks and tips from this video. So whether it's FreeCAD in particular or basic CAD modeling in general with any of the parametric modelers, you will probably learn something from this video.
I think what I learned from this is that I've got to just sort of take the dive and invest my brain in FreeCAD at this point. Amount of design work that I have done has all been in Fusion 360, and it fit my brain pretty well. I started understanding the concepts and knowing where the tools were, and knowing, oh, I want to do this. There must be a tool to do that. Yep, there it is. That kind of stuff. Something like this, investing an hour watching some videos and working through some concrete, actual, real world examples will help me take the leap from what I know about Fusion 360 and the general concepts and put them into another platform. So hats off to Brian for sitting through an hour video and condensing this for us and presenting it in a reasonable fashion. Not that an hour isn't a reasonable amount of time to invest. I'm just saying, everything is hurry up,
Yeah, you can watch it at 1.5 speed. It's not a problem.
That's what I do anyway.
You could jump forward. I mean, the truth is I jumped forward and backward. I probably watched half of it. And what I did, I watched at double speed, but still I picked up good stuff. So, no complaints. If you're going to start up with FreeCAD, there's actually another channel I'll recommend to you. He's done by a German guy, but he has an English series that's equally good, FreeCAD Academy. I'll throw the links in the show notes. He's got some good stuff there. On his German channel, he's using a bunch of the free, as in beer, CAD design tools. I'm not so into the non-open source ones myself, but honestly, if you watch these videos, you will see how similar all of these tools are to each other. I mean, the particulars of where you drag down to get this and what you do to do that is different, of course, but the kind of overarching workflows on all of them is so similar that you learn one, you'll be able to switch over to another, I'm pretty sure. I will say that FreeCAD is not a super finished product yet, and if you want to watch a video that's significantly more critical of it, Thomas Sandlander has done one, which I'll also throw the links in the show notes. He basically, tries to design some parts and runs into a bunch of problems, and You know, again, nothing that's show stopping, but everything that just he feels like it's an awkward tool to use. And I don't think it's because he is necessarily unwilling to learn a new interface. I think he's actually picking up on some defects and weak points of FreeCAD. And so I think it's actually a really good critique of it. Again, I've been using it for the last 2 years now, maybe. If you need to get some parts designed with it and you have the time to work around some of its rough edges, then you will enjoy it. And as with a lot of free software, I think its biggest problem, and this is Thomas's biggest complaint with it, is it actually does too much, and it's overwhelming to have these like 7,000 different workbenches that it presents to you. If you just want to make some little widget that you want to 3D print, you can ignore like 9/10 of the software and just work on your little part that you need to get done. Sketch, sketch, extrude, extrude, done. But it's got so much more, and I think it is presented in a kind of imposing way. You're like, should I be using the sheet bending tool set for this? Should I be working in the pipes workspace? No, you shouldn't. But they're all there, and it's too tempting.
Okay, first up for me is an article I wrote. Flipper Zero smoking a smart meter is a bad look for hardware hackers. This video that this is based on popped up, I don't know when, but I caught it just yesterday. Saw it on rtlsdr.com, and the video purported to show someone using a Flipper Zero, which we all know and have heard about probably at this point, a little sort of all-in-one RF hacking tool, using the Flipper Zero to apparently rapidly turn on and off the service disconnect of a smart meter, an electric meter on the side of a house. And I saw this and I thought, I don't know enough about this to comment on it. Luckily, I've got a guy. I pinged my friend Hash, who is a smart meter hacker. If anybody would have a comment on this, I figured he would. He got back to me within a minute, I believe. He said... He said, I'm working on a video on this. It'll be out tonight or tomorrow. Short story, it's an elaborate hoax. Or he thinks it's an elaborate hoax. The whole setup, the whole box, the meter and everything probably was just purchased from eBay or something like that, specifically for this. As for the turning the electricity on and off part of it, not possible with this model of meter. It just does not have the hardware inside it to turn on and off the service for a house. Some meters do. The ones that Hash works on, Landis gear meters, some of them have a service disconnect so that if you don't pay your bill or there's an emergency like a house fire or something like that and the fire department wants the meter turned off, they can just do that over the air. This one doesn't have that. So whatever the Flipper Zero is flipping, it's not the smart meter. The smoke, smoke's easy to make. At one point, he smoke fills the meter enclosure and leaks out, and he's like, "Oh golly gee," in other words, and but then he continues to do it, and even does the flipping on and off even faster at that point. Apparently thinking, well, a little smoke is one thing, but a lot of smoke is really is better. Anyways, you can go through both videos and make up your own mind. What I didn't like about this was that it really is a bad light to cast upon hardware hacking. I just don't think this works for us. There's people out there who think we do evil things because we call ourselves hackers. They just have the picture of the black hat hackers and the black hoodies, he says, while he's wearing a black hoodie. But I wear that all the time.
How am I going to get coding done if I don't have my hoodie on?
Exactly. But this is a bad look. Even if it is a hoax, people are going to look at this and think, well, that's possible with this little orange thing. We have to ban it. I mean, that's what we're seeing. It's hard to get Flipper Zeros. You can't get them on Amazon anymore. You used to be able to, I believe. They're getting harder and harder to find. This might be part of the reason for that.
The Flipper is super accessible, and it's made a lot of kind of radio frequency hardware hacking stuff accessible. And I think with that, it's gotten extremely popular. And because it's extremely popular, it's drawn some people who are more showy, offy, and maybe to the point that they're faking stuff to get clicks, basically. And I think that's certainly unfortunate. And if it does end up having kind of blowback on the intended audience, which I think is really young people who are curious into playing around with how radio frequency remote stuff works. And like there's all sorts of fun things you could do with a flipper. I'm not against it, and I think that it would be sad if the result of this kind of fakery in particular is to get public backlash against it. Man, Hash's Remoticon talk from 2021. We should throw links in the show notes. That was a superb deep dive into his work with these things. And like I said, he buys all the stuff off of eBay. He's not going to be destroying someone else's property. He's not an idiot. He just buys it himself so he could take it apart. And that, ladies and gentlemen, is the right way to do it. All right, well, my next hack is a totally positive hack. This is a 489 megapixel camera for not a lot by Eunice Zenikowski. This is a fantastic video describing him making a scanner camera. So he takes an old Canon scanner, normal old bed scanner, and converts it by buying some old projector lenses and doing a bunch of 3D printing into a camera. And this, of course, is not a camera like you're thinking of. It doesn't go click and the photo is taken. Instead, it goes zzz and the scanner moves down. But by doing that, of course, you get the whole 1200 DPI across the whole frame, and then it moves on down. You get a whole ton of pixels. And he's actually exposing it most of the time at a paltry 143 megapixels. But he does push it at one point up to the full 489. For those of you who care, I'm totally happy with my camera that shoots a measly 24 megapixels. And these images start getting outrageously large, not just because of the resolution of the sensor that comes out of it, but also because it's got more color depth. It's got more bits per color channel on these scanners than an average camera. It's a really, really cool build, and he goes through a lot of the problems and the things you wouldn't have thought of that come about from scanning slowly across the whole field as you expose the image. One of them, I guess, that I really hadn't thought about, he's doing some pictures inside and it works out about right. And then he takes it outside and it's capturing all the infrared because, if you imagine a scanner, right, it's got like an LED illumination bar on it. It's not going to be putting out any infrared. So they don't bother putting an infrared filter on it. So, if you don't want to be taking infrared photography, then you need to get rid of that. But man, that made me think, ooh, this is an awesome ultra high resolution infrared camera. If you just block the visible light, this could actually be, you could take it the opposite direction. That would be super cool. One of the other things that's weird about it is that it exposes each line separately. So, if you imagine you put a piece of paper in a bed scanner, it exposes them all at about the same, but in case there's more light here or less light there, it does automatically adjust the exposure as it's going across the paper. If you're doing this outside, that's kind of a weird effect. And he has cars coming through one of these pictures he took in a garage and like shining light on it. And this causes strange banding and stuff like this. So there's actually a whole bunch of image processing he needs to do after the fact. But like just having a scanner go across it means you can do all that fun slit scan stuff. Plus, it's got so much resolution that he can do like the zoom enhance thing, essentially up to the limits of the lens he has on it. And he's using cheap lenses, but when you're pushing 500 megapixels, you don't have a lens that is going to put out that much resolution. So either you're going to spend a lot of money on glass, or that's not going to be your limiting factor.
The basic setup here kind of reminds me of what they did for the Viking lander on Mars for a camera. I think it had two cameras, but basically it had a vertical line of pixels and a camera and a lens and a mirror that sort of did a swipe across the scene, a vertical slice of the scene, and then it moved over a degree or a half a degree or something like that, did another one, moved, and it just continually rotated across this and taking vertical slices of it. I thought that was a genius way to sort of take high resolution photographs in 1970 whatever 76. I also thought it was kind of neat because they used the Voyager cameras to take a picture of the Viking team while it was still on Earth, and they basically had a whole bunch of people set up in this portrait people on the left could leave before the people on the right had even been photographed. And then some people from the left came around the back and went on, got into and sat down again. And so there are two versions of the same person in the picture, of course. And now all this makes me think I should probably do an article on the Viking cameras and how they worked, because they were pretty cool. So anyways, that's what this reminded me of. And I thought this was pretty cool.
Yeah, too right. And actually, Greg Garris comes in the comments and says you could do this with a panoramic setup, right? Like you, instead of holding the lens and the camera still and sliding it across, you can pivot as you're doing that. And you can get kind of, and I think they did this on Viking, you can get these like super low distortion panoramas because you're not looking at the edge of a fisheye lens. You're always looking straight down the middle of the lens. You're just sweeping the scanner across. But you could be doing this. And anyway, the point of this hack is that these scanners are cheap and available. I think he was talking about one that he picked up used for like $50. He's using a cheap projector lens here. So, it's a $40 lens. If you can find any old lens, you can use that too, right? Like that part's not critical. It's all 3D printed and modular. I think this is something that is wide open for experimentation and just begs to be played with in all of these different directions, like whether you go IR, whether you go panorama, or, whether you try to do something crazy cool with the ultra high resolution you can get out of this. The only thing you can't do, of course, is stop motion because, it takes a few seconds to expose the whole plate. But it actually looks like it has decent low light sensitivity. I mean, he was taking pictures inside, so it's not like you have to light it up too much. It does blow out if you expose it too much, but what sensor doesn't? You just have to stop the lens down. Anyway, kind of inspiring and inviting you to do something like this and play around with it. And so I think I love this work just by itself, and it's really awesome that he put out the 3D designs for his camera, et cetera, et cetera. But I think it's more also of an invitation to kind of rustle up $60 worth of parts and do this for yourself.
Okay, next up for me, do not attempt disassembly, analog wizardry, and a 1960s frequency counter. Could you hang redder meat in front of someone like Curious Mark than to say, do not attempt disassembly? There's good reason for a sign like that in a machine such as an HP 5245L frequency counter from 1963. This is a entirely discrete component, magnificent example of engineering that was the hallmark of Hewlett-Packard back in the day. Mark himself, Curious Mark, is on a first name basis with Mr. Hewlett and Packard. He refers to them as Bill and Dave at one point in the video. And there's good reason for that too, because he is the Hewlett Packard surgeon of last resort here. This is where HP equipment goes to his lab to live again. And some of the things that he has brought back to life are truly amazing pieces of technology, back from when I remember someone saying that Hewlett Packard used to be a company populated by geeks making stuff for geeks. That's what this is. This piece of equipment is a frequency counter that went for an astonishing amount of money back in the day. Mark shows some pictures of it in consoles in the Apollo communications facilities in Australia. There's probably a half dozen of these frequency counters sitting in these consoles. They're fabulously complex because they had to do the job that they were asked to do. The interesting thing about these counters is they have this kind of a module spot, a pluggable module in the front panel that you'd put adapters in for various frequency ranges. This thing could go up to 18 gigahertz, which was pretty amazing for the day. And the way that it does it was remarkable. Most of the modules that he got were non-functioning and mostly for mechanical reasons. Apparently the grease that they used for the gears on these things dried up and turned into basically a glue. He had to disassemble them all and dissolve that. Once he did that, got it all back together. The mechanical aspect of it actually is for moving components inside of the resonant cavity to basically tune the LC circuit that these parts make when they're in proximity to each other. it's all fascinating RF engineering stuff that gets into the super wizardry area that most of us can only dream about mastering the way that Mark has. His way of presenting it all is fascinating too. The thing that really took me by surprise in this instrument is the sheer number of transistors that they threw at the problem. I mean, the transistor in 1963, the transistor commercially at least is only like 10 years old at this point, probably, right? They just extravagantly threw individual transistors at the job. And more so, some of the circuits were absolutely dependent on a specific kind of transistor, most of which are no longer available. And some of the times, some of these circuits were actually dependent on a specific transistor itself, the characteristics of that specific transistor, and other components around them were tuned to match the characteristics of that transistor. It's all, had to be incredibly hands-on, incredibly labor-intensive to produce machines like these, and the price probably reflected that to a large degree. Anyways, you check out the entire series. I believe there's 3 or maybe even more videos than that in the entire series. I've been watching them, and it's just great to take a look at the inside of these machines and get a guided tour from Mark, who knows their internals pretty intimately.
He's got all of the schematics out for these machines, and I just love the way they were built to be repaired and, built to be diagnosed back in the day. And then at one point he pulls out the microfiche machine to read some of the schematics for these things in microfiche. And I'm just totally laughing. I tell you what, I'm a little bit of a synth geek, and in one of those shots, he's playing with an oscilloscope or calibrating something, and I'm like, that's a Roland Juno 60 in the background. He's got a sweet synthesizer there that I'm sure isn't working and somebody is having him repair. But that's not bad. Sweet old vintage synthesizers to boot. I want to move in.
Oh my God, his lab, right?
Right?
If I'm ever in I believe he lives in the San Francisco Bay Area, someplace in the valley, he ever even hints at saying it's okay for me to stop by someday, I will get on a plane, make myself appear there just to get a look, at all that stuff that he's got in that shop. It looks like it's the entire basement of his house, and there's a machine shop over here, and then there's the HP lab over here, and then there's the place where he builds the R2D2s over here. Amazing.
I hear you.
I'd love to drop by. We're practically neighbors, right, Mark? I mean, I'm in Idaho, you're in California. It's like right next door.
All right, and my last hack this week is actually a fairly simple one by Rasduino Uno. This is an Arduino-powered missile system, uses ultrasound to aim. And what I like about this is I just love those little HCSR04 ultrasonic ranger modules because A, they're dirt cheap, B, they're tremendously easy to use. They're tremendously easy to use in principle, I guess I should say, but in practice, they're full of challenges and mysteries, and sonar, the sound just bounces all off everywhere, and the cone's wider than you think it is, and it actually provides a really interesting challenge if you want to start playing around with these things on a tremendously cheap budget, because you could pick up like a 10-pack of these things for $10. So I do like seeing these projects, and this one, it's a pretty simple setup. It's got like a pivoting sonar unit, and then it's got a pivoting Nerf turret that shoots at things. The sonar pinger sits on top of a servo motor that's driven by an Arduino. The Arduino actually just tells the Raspberry Pi that it's connected to over serial, what angle it's pointing at and what the range it has to whatever's reflected is. And then the Raspberry Pi graphs it. I actually really like the way he did, I think in processing, hooked up a little screen to the Raspberry Pi, and you can see the ranges at all the different angles as like it was one of those old-timey radar displays. And I think that's just really cool. And also, again, like I said, using these sonar things in practice is hard enough that you actually want a really good visualization of it if you're going to try to debug a system like this. in the end, he has it like fire at a Lego figure, but I went looking through his code to see how he did that, because that's the hard part, is figuring out, where the center of your target is, because you've got kind of a 15-degree wide cone on these sonar units. And I think he must have just shot it straight with his hand for the video. I think he must have done that manually, because I couldn't find anywhere in there where it did the really hard signal processing that you'd have to do to have it pick up a small feature like that. So I'm not calling it a fake. I still think it's a really fantastic ultrasound project. But at the same time, the part that I wanted to see, which is how he did the really hard part, I don't think it's in there for you. That is, again, what I think is awesome about these ultrasound projects, is that the material's all cheap enough, but the problem itself is actually really hard. So it's like an invitation for you to get in a little bit deeper than you know what you're doing, which is always where you learn new stuff, right?
Yeah, I mean, ultrasound is always in that sort of noisy realm, right? I mean, take a look at those the ultrasonic levitators that we used to see a whole lot of. No matter how finely tuned the loops are, there's always some wobble to that little piece of styrofoam or a little fleck of bug or whatever it is that they're using to levitate. And there's nothing you can do to get rid of that wobble. That's showing you kind of the noise that's in the system. And, ultrasound noise, I get it, right? But you know what I mean? There's always a noise floor in these things that is kind of hard to get over. And I mean, you even see it in medical ultrasounds. When you're watching, the big reveal of seeing your baby for the first time on a medical ultrasound, you're like, oh my God, that's just so amazing. You're actually seeing it in real time on the screen. And then they give you the little Polaroid and you're like, the hell is that? That doesn't, that specularity or the data that you're getting from the way that pixels are sort of accumulating on the screen, flashing on and off, you lose all of that. It's so clear when you look at it. Yeah, it's so clear when you look at it on the screen, and then they hand you the still. You're like, okay, well, thanks. There's my blob. Granted, my kids were, born in the late 90s, or in early 2000s, so things have changed considerably since then, probably, but still.
Nope. not all that much.
Not that much? Okay, good. It's not just me being an old fart then. But anyways, finding the centroid of a target like that, would be a difficult task amid all that noise, and I don't really think that's the point here. This clearly is something to get kids thinking, that electronics are pretty cool. And I think it does that very capably.
Yeah, someone says that in the comments, that this would be like a great science fair project. And that's, of course, totally true. I also want to use this opportunity to give you like my brain dump of awesome ultrasonic sensor links that you should check up on Hackaday, starting with 2014's Good Vibrations giving the HC SR04 a brain transplant. Emil reverse engineered the whole thing and put a different microcontroller in there, desoldered the one that's on it, put a new one in so that he could program it himself and get better access to the raw data. And that's just a sweet hack, and it turns a piece of commodity crap into something you can then start to do real work with. Building on that, actually, it might be worse. 2017, measuring airflow with ultrasonic sensors, does the same thing and then uses the bounce return time down a pipe to measure how fast the air is moving through the pipe. That's a great hack. Graham Chow, El Cheapo phased array sonar, takes these little devices and hacks them into I guess it's only a 2-element phased array, but he's able to get a little more beam steering out of it. That's really cool. These things are so cheap, you can just stick 8 of them on your robot, for instance, and that's what happens in Octosonar, is 8 times better than Monosonar, which is basically a microcontroller programmed to sample all 8 of these units and then report its values back over I²C. And then last but not least, 2018's dual sensor echolocator gives high accuracy at a low cost. Lingib did this one. It's basically aiming 2 of them across each other and kind of triangulating where something is in 2D space. And he gets really good resolution by just using 2 of them and crossing the beams. So that's a really cool experiment there too. There are more. If you look up ultrasonic sensor, or ultrasonic ranger, or HCSR04 on Hackaday, you will find a million more. These are my favorites from the past decade. Links in the show notes.
Links, plenty of links. Jeez, I saw that.
Take that, links in the show notes.
Yeah,
I got like
all right,
8 of
I'll
them.
I'll have to make sure I put some links in my show notes. the links gap here is.
I frankly was abusing that for a links dump. I mean, that was what I wanted. I had those coming. Those were building up in me.
It looks like it.
I like ultrasonic sensors.
Okay, last up for me, recreating an analog TV test pattern. This one comes to us from Matt's TV Barn, which is just what it sounds like. It's a place where old TVs go to live again and old TV technology. So it's pretty fascinating. And I mean, I was in the video business in the late 1980s, early 1990s. And this kind of stuff is great for me. This particular test pattern generator lived on a sort of an optional card that was plugged into a digital sync generator that would have lived in a rack of other equipment that would be in a TV studio or something like that. And it generated what Matt claims is the most recognizable TV test pattern of all time. I'm going to quibble with him on that because it depends a lot on where you live, I think, which TV test patterns you saw a lot of. The test card F that was popular with the BBC. It had the little girl with the doll in it. That was a popular one that probably a lot more people are familiar with. The Indian head test patterns from the black and white days, or even the simple NTSC color bars, part of which appears in the center of this particular Philips test pattern. But anyways, he has this sync generator, but he doesn't have this add-on card that actually generates the test pattern. What to do other than reverse engineer it? Luckily, Philips has made all of this stuff open source, which sort of let that sink in for a second. A major company like that making some of their stuff open source. All the information's out there, including the drawings for the original PC board. So that's kind of where this whole project started with reverse engineering the PC board layouts and bringing them into modern standards. And that was all a very touchy process that it took Matt quite a while. It's a 6-layer board. It was the risk of getting something wrong in one of those layers was pretty high. But he sent the designs off to get processed, and you come up with this big board. You know, it's quite a lot of surface area and a lot of parts to put on it, including an awful lot of very big, I think those are PLCC chips, the ones that actually plug into the sockets. Anyways, he had to populate this board with an awful lot of parts. There was a big analog section of the board that had to get populated too. And there were even parts that weren't available anymore. Some RF chokes that he couldn't find any supply of, so he had to wind his own RF chokes. The adjustable inductors just not made anymore, so he had to buy the closest thing he could find, open the cans up, take the guts out, rewind those for the specs, and put them all back together so he could just then solder them on the board. It's really a tour de force of reverse engineering and reverse programming, making your own components, making your own PC board. Absolutely everything is there. And when he plugged it in, what do you know, but it worked. Got the test pattern out. And it's a very complicated test pattern, too. There's a lot to it. Lots of grayscale stuff, areas for tuning linearity. And it looks great. It looked fabulous on an old analog TV. Again, which one's the most popular one of all time? Who knows? But if you're into test cards and test patterns, then this one will really have something to show you.
Yeah, it's absolutely terrifying, and it really makes you appreciate the kind of ease of building things digitally, and with all monolithic parts and with better, faster parts, and just throw a fast microcontroller in it, for God's sake. This thing has so many parts. 6-layer board, like you said. Like, I guess some of it is the analog front end or whatever, the analog amplifier section that he spends all that time calibrating and tuning. And of course, if it's a test pattern, when it puts out a straight line, it has to be a straight line because you're going to be calibrating your TVs to this. So, again, like the insides of some of those old scopes that Curious Mark is taking apart, this is the serious deal, and getting it tuned up right is the success or failure of the device. But man, talk about complicated, talk about dedication.
I mean, just the reflow on that board, being that it's so much surface area, he was really worried about that, not having a reflow oven. And even if you did, you might not have, especially if you built one out of like a toaster oven or something, this board probably wouldn't fit. So he had to come up with a way to do the reflow. And what he was really worried about was getting the board cooled down at the right point. And so he came up with this great little robot that basically just lifts the board right off of a hot plate. And then he takes a couple of fans and he's cooling it down, that's sort of ad hoc, that bit of it. But that little board lifter was a really cool idea, and you could see that being generically useful for any kind of big reflow job like this. Really a labor of love here, because seriously, you could just take a PNG or a JPEG of this test card and put it on a Raspberry Pi or an ESP32 or something like that and be done with it. But no, he wanted it to be the real thing. And like he said, at the end of the video, he said, "Don't tell my parents I spent this much time generating a test pattern." He knows that it was a kind of a crazy thing to do, but we appreciate the craziness because it came out great.
My first quick hack this week is BIOS postcard built using Raspberry Pi Pico. This is some quick work by Mr. Green. If you've got a computer that's firing up and it's spitting out those post codes, power on self-test codes that tell you what's wrong, but it uses the serial protocol so you can't tell what's wrong, you can flash this into your Raspberry Pi Pico and it'll tell you. Next up, Diego Pisanti's blind camera visualizing a scene from its sounds alone is a really cool art piece. It uses a neural network trained on pictures from his native Mexico City and their sounds. Then it turns off the camera and tries to regenerate the pictures from the noise it hears. Of course, what this means is that everything looks like Mexico City, but it's a really cool experiment. I just like the idea of hamstringing the neural network after you've trained it. And then last up, Alex Taradov, cheap USB sniffer, has Wireshark interface. This is a tremendously useful tool if you need to do some low-level USB hacking. This is basically an FPGA and a couple USB interface chips, but it then spits out its data off to Wireshark. So you can do kind of packet-level Wireshark analysis of it. So if you want to be doing some work that is higher level than like rise times and the kind of physical layer stuff, for which you need a fantastically expensive oscilloscope these days, or anything below kind of the application layer where you can plug it into your computer and ask your computer what it thinks. Anything in the middle there is at the level where USB is kind of like a network. That's where you want this device to take these raw packets and send them over to Wireshark. Really cool. There's a bunch of devices like this out there. This one is Alex's, and he actually comes into the comments to talk about the design decisions and trade-offs. So it's a nice piece of kit if you need to do some low-level USB.
My first quick hack is plastic welding revisited. Now, last time I was on the podcast, I did talk about a plastic welding hack that probably wasn't actually welding, involving nylon wire ties and a hot glue gun. This is kind of that same bent, but I don't really care. A fix is a fix. This may not be welding, but okay, so what? There's a whole bunch of different tips for fixing broken plastic with a soldering iron, wire reinforcements, different things like staples, different ways to melt the plastic together and get them put back together. And yes, it does use some nylon wire ties. Next up, a peek inside a 747 fuel gauge. This one comes to us from Biker Glenn, and he has been doing a lot of avionics and avionic related projects lately. This one is a great looking old 747 fuel gauge, which is nowhere near as simple as the fuel gauge in your car or the one on your lawnmower. This one can measure up to 95,000 pounds of fuel, and it uses an AC servo and some very complicated clockwork mechanism to actually display the levels. Glenn actually manages to drive it and show us what different fuel levels would look like. What I'm curious about is what the sender looks like. What's the sensor for how the fuel is detected in the tank, but maybe we'll find that out in the future. Last up, magnetic bubble memory brought to life on a Heath kit. Now, this is from Dr. Scott Baker. We've seen quite a few of his videos over the years, and he's got this old Heathkit Intel 8080 based computer that he's been working on. I'd like to say that I never understood bubble memory before, and now I understand it better. I can't really say that. I think now the best I can say is that I misunderstand it a little better than I did before. But his demonstration of how the bubbles move in the tracks inside the memory chip is pretty effective. The use of the marble race metaphor is kind of handy. Anyways, he manages to get bubble memory working on his old 8080 computer, and it's pretty interesting. You should check it out.
That brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And I want to start off with Jenny lists, why did the Home Assistant future not quite work the way it was supposed to? I guess this article was kind of spurred by the news that Amazon and Google are kind of backing away from their voice-based home assistants because they're just not making them any money. And this article is basically Jenny saying, well, what happened here? I'm kind of on the tinfoilier hat end of the spectrum, and I really hate to have these devices that could be potentially listening to me all the time in my home. Nonetheless, my wife got some, and we used them for a while, and they were kind of useful for a while. I guess we made lists, shopping lists using it. Alexa, put mayonnaise on the shopping list kind of thing. But other than that, I think the truth is we ended up just not using it much. So that's kind of like our consumer disenchantment side. And I think the only one we still have going is the one my son uses to listen to music on because he's 9. And the rest of us have, better things to do. And I don't think we're alone. On the other side, on the Amazon side of things, I think they didn't make any money on it either. Their idea, I guess, was to have these make it become so easy for people to place orders on Amazon that they would just do it all the time. And I think it must not have actually mattered to them. I mean, I don't have their numbers, only they do. But my guess is that, they just didn't think it was worth it. Plus, they were selling these devices for basically what they cost to make. So they were selling them cheap enough because they wanted tons of them out there. But then that meant they weren't making money on selling the devices either. And so if they don't drive extra sales and they don't make money on the hardware, what's in it for Amazon? And we're all kind of it was really fun for a while to be able to say, turn the lights on in the bedroom and have them come on. But then after a little bit, the thrill of that kind of somehow wore off, and against all the other inconveniences, like it can't hear you when 2 people are talking at the same time. Or I guess when we first got it, my son was a lot younger, and having a 3-year-old is a denial of service for an Alexa. I don't know. What do you think? Do we need voice-powered home assistants?
It depends on when in my life you asked me that question. If you asked me that when I was 12 years old and there was somebody building a voice-controlled, robot,
that would be so awesome,
or something, I would have been like, oh my God, I've got to have that. I've got to build that myself.
Yeah.
Or even 1983 War Games when David's got a computer that's talking to him. Oh, got to get me some of that. Yeah. Even probably 20s, 30s me probably would have said, oh, that's really cool. I would love to be able to, talk to my computer and have it talk back and order things and all that. But the reality of it, now that I'm not that young and now that I know what these companies do with data, I never let one of these things anywhere near my house, and no one in my family. I mean, we've played with them on our phones, the personal assistants on our phones, and all that, and asked for the meaning of the universe and or life universe and everything, and we get a 42. Ha ha! Isn't that funny?
Once.
Yeah, once. And you turn that off. There's no way that stuff is going to be listening to me all the time and sitting there, doing its thing. I mean, I guess the main problem for me is that Amazon's model or prediction of what I was going to use something like this for was just not going to work. Take out the paranoia and the not wanting to sell my information, all this stuff. Take all that out of the equation and just say, what was the value proposition that these things represented from Amazon's point of view and from my point of view? Like you said, it was going to make it easy for us to order stuff from Amazon all the time. Okay. The stuff I order from Amazon, however, is stuff I need to look at. I need to, I ordered, I need ball joints from my truck, and I needed a picture of them to be sure that they were going to be the ones that fit my truck. Now, I didn't buy them from Amazon. I bought them from Toyota because I'm not stupid. But I got a chance to look at them, and I would not be able to do that. The kind of stuff that I order from Amazon, or the kind of things that I want from Amazon, are visual feedback sort of things. I don't need Amazon to send me wheat thins or mayonnaise, like you said. I'm not going to do that. The stuff I want from Amazon is stuff that I need to look at, and this provides me with no satisfaction. I can't just say, send me some ball joints for a 2004 Tundra.
And it's not just send me some ball joints. You really need to get the right part. And figuring out from the bad Chinese to English translations on Amazon which one of them is the right part is not easy. And I can't think of anything that we would order blind on Amazon. And actually us making a shopping list was not an Amazon shopping list. Bear in mind, this was us making a shopping list because we needed to actually go shopping and buy some mayonnaise when we were out in a store that wasn't Amazon. We weren't ordering random mayonnaise from Amazon. I mean, that's just not my lifestyle, I guess. I don't know what's wrong with me. But But yeah, I think that's it, right? I think if you want to comparison shop, or if you want to look around for different things, or if you want to make sure it's the right one, or any of that, that's a be looking at a web page type experience. And so it's not useful for that. I don't know. It just seemed so Jetson-y at the time, right? It seemed so like we're living in the future. And I know a ton of Hackaday readers, writers, all of us were playing around with these things because it was really cool to have voice control of a whole bunch of things. But then I think, I mean, maybe I am just speaking for myself, but technology and all the rest of our lives caught up, or, the thrill is gone somehow. I don't know what happened. I think the only thing left at this point is the sketchy, them spying us out stuff. And if that's all that's left, I think it's time to pull the plug on it anyway. I will say that we did set up a special router for it when we first got it. We actually put it on my old WRTG 54 as a quarantined network, just to watch the network traffic going across.
Sure.
And it was all encrypted. So I don't know what the content of it was, but the volume of it was not disproportionate to their claims that it's only sending after the wake-up word. I never saw any evidence of it spying on me. There were some times when it thought it heard the wake-up word and it sent something across, but that's just the error rate. That has to happen, I'm afraid. I don't think we ever caught them. And that's not saying we're a target of interest. And, if I were, if I had real privacy concerns, I sure as heck wouldn't have one of these in my house. But even as just a casually privacy interested person, we did a lightweight audit of it and it looked kind of clean. And I think instead it just died of boredom.
Okay, my pick for Can't Miss article is from Al Williams' SpyTech series, SpyTech Unshredding Documents. We had a little talk about this in the editors meeting some weeks ago, and just in general talked about what the capabilities are regarding reassembling shredded documents. And, is that a risk vector? Can shredded documents be reassembled? Is anybody actually doing it? And we all just assumed, yeah, of course. I mean, we've all seen the movies, and, you take a shredded document and you put it in on the bed of a scanner, or you throw it into some sort of device, and a computer goes beep, boop, beep, and the reassembled document with the incriminating evidence comes out and stares you right in the face. That's how it works, right? Well, maybe not exactly. The article is specific for the East German Ministry of State Security, which we all know as the Stasi. East Germany, of course, ceased to exist in 1989 or so. But the paperwork that they accumulated over the decades remained. A lot of it in shredded or torn up condition, because when they saw the writing was on the wall that was about to fall, they started covering their tracks and shredding and taking care of all these documents. There's still something like 16,000 bags full of shredded documents that remain today that need to be gone through, because they have information about that whole dark period of time during the Cold War and sort of the atrocities that were committed, and the just general crimes that were documented. What's more concerning, though, is perhaps the presence of the names of informants, which apparently sounds like, from the way that Al describes it in his article, every other person was an informant in the DDR. So you have a whole lot of political weight to what's in these bags. And there's also kind of an archaeology thing that goes on in these bags. The order of the items that's in a bag reflects the time that they were put into that bag. So you can't just kind of rifle through a bag and take a bunch of, you can't just dump them out onto a table, for instance. Each layer has to be kind of dissected, much the same way that that archaeology dissects layers of sediment and sand and stuff like that. Because where that object is inside the bag gives you information about that document. So it's a painstaking process to go through these bags. They've only done, I think, 3,500 bags, something like that. A ridiculously small number of documents have been recreated for the amount of time that's been devoted to it. But there's a reason for it. Like I said, 327 bags in 13 years. That's what 36 archivists. Ridiculously slow process, but understandably so for the task at hand.
This is one of those problems that you think is going to be easy going in, because they've essentially got the reassembly of banknotes system down. And this is just that, right? It's just torn up bits that have to be put together. But they're all totally irregular. None of them match each other. They're thrown together, with thousands of pages per bag, shredded into thousands of pieces each, and they're all mixed with each other. The scale of the problem is so different that I actually believe this was a job given to some people at the Fraunhofer Institute. I actually believe that they went into it thinking this is going to be a technologically possible solution, and just in the end just got walloped by the scale of it, which is so much bigger than anyone thinks. Al linked up some posts here of people doing document reconstruction and stuff like this, but these are people who have 10 pieces of paper shredded, and they know they have only these 10 pieces of paper, and sometimes they have horizontal lines in them that cut across the shreds. I mean, these are really easy cases. The Stasi documents, a lot of them are handwritten. They're, completely irregular. It's just even scanning them in, they're all shredded, crinkly, is an absolute nightmare. I just think this is one of those problems that on the face seems like it should be easy and then ends up being just entirely impossible.
wouldn't it be great if you could just like take the entire contents of a bag, throw it through some sort of, tube that blows it along with air, and a bunch of cameras take pictures of the fragments as they go by and knows when, it matches up the text from one piece with a piece from a camera, an image from a camera that's farther down the tube, and it knows that the same piece. I mean, you could think of fanciful situations where you could come up with the hardware that would do this quickly and easily, and then, there would be no point in shredding documents. You would have to absolutely destroy them in burning, mulching, I don't know what, pulping, I guess would be the best way.
I don't know. There's some doubt, I think, in the comments, and Al may have even seeded it in his article about whether there's political will to reconstruct these. And
right, yeah.
I don't think that's appropriate. I mean, the truth is these documents were seized, right? Like the DDR government got knocked down, and 90-something% of all of the documents were seized intact before the people who were trying to hide stuff could shred them, which does make you think that the good stuff is in this remaining 5%. Which 5% are you going to shred? The really incriminating stuff. So, there's probably there's definitely real incentive to get in here. The vast majority of the Stasi records were actually retained because the East Germans, after the government fell, took them and preserved them to say, hey, look, this is what the secret police were doing to us. And there's these huge document centers here. So I don't actually buy the conspiracy theory stuff here so much. I think there's actually extreme on the opposite side. I think there's real will to set the record straight, because this is kind of widely viewed, at least in Germany, as a tremendous crime against humanity. And it's probably part of the reason that the Germans are so much more worried about security, information security, government surveillance than Americans are.
I guess basically what you're saying is the Stasi was nobody's friends.
Nobody liked the Stasi.
Yeah,
no,
so
that's why the government got overthrown. Yeah, and again, the scale here is, I just had to do some of the math. Al mentions that there were 16,000 bags with about 45 million pages in them. And so, divide that up. That's each bag has 2,800 pages in it. And then over the course of 13 years, so took them forever, but they did actually manage to reconstruct about 1 million pages. So it's not that we're saying this is an impossible problem. Like, 1 million pages were reconstructed. It's just the scale of the problem is 45 million pages need reconstructing. So, what are you going to do with the remaining 44 million? Yoicks. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you'd like to check out the links, head on over to hackaday.com/podcast. And as always, if you see something cool or do anything cool, write us an email, tips@hackaday.com. And until next week,
keep on hacking.
Recording here. Oh, that was weak. I've got my ears on. What are we going to do? Oh, excuse me. Burp.
Well, now we're in trouble.
Crap. I'm going to cut half of that.
Okay, my first quick hack is plasting.
Cough, stretch, and let's bring it on home.